Hey, multiplication fact strategy teachers. Today we're going to talk about the more area compare strategy. The more area compare strategy is a strategy for solving an unknown multiplication fact, where you take a fact you already know and you compare it to a new fact to see how much more area the new fact has than the benchmark fact. So let's take the example of 5 times 7. If 5 times 7 were a new fact for me, if I did not know 5 times 7, I could compare it to the fact 5 times 6, which would be my benchmark fact. 5 times 6, of course, equals 30. And also, 5 times 6, of course, is 6 rows with 5 in each row. 5 times 7 has 7 rows with 5 in each row, so it has one more row of 5. 30, the area of my 5 by 6 rectangle, plus an extra row of 5 that the 5 times 7 rectangle has equals 35. So 5 times 7 equals 35. Let's take a look at another example. Here's the new fact 6 times 3. And if I didn't know 6 times 3, I could compare it to the benchmark fact 5 times 3. And you can see here I have an area model representing this as well. 6 times 3 is my new fact. My benchmark fact is 5 times 3, which I know equals 15. I immediately notice that 6 times 3 and 5 times 3 have a common factor. They both have a factor of 3. And when I look at my area model, I notice that that same number, 3, is the number of squares in this extra row that 6 times 3 has. That makes sense because 6 times 3 means there are 6 rows of the common factor 3, and 5 times 3 means that there are 5 rows of the common factor 3. So of course, my new fact 6 times 3 has one more row of 3, one more row of the common factor. Since 6 times 3, the new fact, has more area than the benchmark fact, it has one more row, it has 6 rows of 3 instead of 5 rows of 3, we add that extra row of 3 to 5 times 3, so that now there are 6 rows of 3. 6 times 3. 15 plus 3 more equals 18. So 6 times 3 equals 18. It is pretty common to find that students have a difficult time knowing when to use the more area compare strategy, or a difficult time determining benchmark facts to use to solve unknown facts. So it can be really helpful to intentionally teach our students when to apply certain specific strategies. So for example, it's great to teach students that the more area compare strategy is really helpful to solve 3's facts that we don't know. More area compare is helpful for solving 3's because 2 is always a great benchmark for 3. So if you don't know a 3's fact, you could use a 2's fact with the more area compare strategy to solve it. So if I didn't know, for example, 3 times 6, I could compare it to 2 times 6. You'll have to forgive my handwriting. 2 times 6, of course, equals 12. And I immediately noticed that 3 times 6 and 2 times 6 both have a common factor of 6. So 3 times 6 means there are 3 rows or groups of 6. 2 times 6 means there are 2 rows or groups of 6. My new fact, 3 times 6, obviously has one more row than 2 times 6. So I add that one more row of 6. 12 plus 6 equals 18. So 3 times 6 equals 18. In addition to being helpful for solving 3's facts, the more area compare strategy is also really useful for solving 6 facts, and I like to directly tell my students that. More area compare is helpful for solving 6 facts because 5 is a great benchmark for 6. Anytime we have a multiplication fact with a factor of 6 that we don't know, we could always compare that fact to a 5's fact. So if I did not know the fact 6 times 8, I could compare it to 5 times 8. 5 times 8 equals 40. And I notice that 5 times 8 and 6 times 8 have a common factor of 8. 6 times 8 is 6 rows of 8. 5 times 8 is just 5 rows of 8. So 6 times 8 has one more row of 8, so I need to add an extra row of 8 to 5 times 8. 5 times 8 plus one more row of 8 will equal 6 times 8. 40 plus 8 more equals 48. So 6 times 8 equals 48. More area compare is a great strategy for students to use, and it is particularly helpful for 3 facts and 6 facts. Happy multiplying!